Okay, so today we are going to start with Kirchhoff Voltage Law. Kirchhoff's Voltage Law. It comes under this chapter, current electricity, and in current electricity, this is the first time when we are going to discuss the law of conservation of energy. The law of conservation of energy. How? Before that, in electrostatics, we discussed the concept of potential energy. Okay, when the charges are transferred, how the potential energy is altered, and what is the change in potential energy, what is the work done by electric field, what is the work done by external agent, all those things we have studied. But now the electrostatic part is over and we are into current electricity. Now the charge is moving. In case of current electricity, from where the energy comes and where it goes, where it goes, that's all is given by Kirchhoff's voltage law, which is nothing but a restatement of law of conservation of energy. How it is restating the law of conservation of energy, we will see. We will discuss the statement of Kirchhoff's voltage law within a couple of minutes. First, let's see how energy comes and where it goes. Let's take a circuit. I am drawing a simplest, very simple circuit with one resistor R with uh, let's say a capacitor, a parallel plate capacitor of capacitance C, and there is a battery here. The battery has a EMF. Now, this is the lower potential plate. This is the higher potential plate of the battery. Okay. In this battery, the current will originate from the higher potential, and let's make a key as well. We'll make a key here. Little bit. Okay. I am making a key here, and I'm closing the key at time t is equals to 0. As I will close the key, the current will start flowing here. Whatever is the value of current I which is flowing, the current will go through this branch. Through this branch, there is no other branches present, so current will the current will keep on going in this way. Since it is not steady state, since we have just closed the circuit, the capacitor will also pass the current, and the current will reach back here. What is current? Current is basically some charge which is going around in the circuit. Let's say some charge plus Q which is going around in the circuit. Okay. So this plus Q, let's say we are starting from here and we are crossing this battery. So in this battery, this is lower potential plate, and I am assuming this lower potential is 0 and the higher potential is E. So that the potential difference provided by the battery is, it is an ideal battery, and the potential difference provided by the battery is E. Now when the charge goes from lower potential to higher potential, it will gain some energy. How much energy it will gain? The energy it will gain will be equals to Q into potential difference. Right? So the charge is Q, the final potential, because the charge is going from lower potential plate to higher potential. So the higher potential is E, lower potential is 0. So the battery will give the charge this amount of energy, QE amount of energy charge has gained. So I am writing QE amount of energy charge has gained. We cross the battery. Okay. This is an ideal wire. This complete here is an ideal wire. There is no resistance or anything present. We will say that there is no element present here which can contribute in potential or which can drop the potential. Now, since the current is passing in the resistor from left to right, we will say, because in any conductor the current will pass from positive to negative, positive to negative, positive to positive, positive to negative, positive to negative, positive to positive, positive to negative, 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 you can say that high potential to low potential. Okay, what is the potential difference in the resistor? I will say it is IR by Ohm's law. I have assumed that the current I is passing through the resistor. So what will be the potential difference? IR. Which will be the higher potential? This one. This is the lower potential. So if the charge Q will cross this potential difference, it is going from higher potential to lower potential. So it must be losing some energy. How much energy it is losing? Minus, first of all, because it is losing, and second, how much potential difference it has, the it has been through IR. So minus Q into IR. We know that the formula is simply Q into potential difference. The energy gained or energy lost depends on whether it is going from lower potential to higher potential, it will gain energy, or it is going from higher potential to lower potential, it will lose energy. So in case of resistor, it is losing energy minus Q into IR. Then it is crossing this capacitor. The charge is also passing through this capacitor. It is coming here. Across the capacitor, the potential difference is how much? Potential difference, let's say across the capacitor is, let's say Vc. Okay, it depends on how much charge the capacitor is having. Okay, charge of the capacitor divided by its capacitance. Okay, so there must be some voltage across this capacitor. Whatever is the voltage across this capacitor, I will write that my charge is passing through. This is the higher potential and this is the lower potential. Okay, because this plate is connected with the higher potential of the battery, so this must be charged with higher potential. So charge is going from higher potential to lower potential. So it must be losing energy. So uh, I will not use the plus sign here. I will use a minus sign here. I will use a minus sign Q into, what is the potential difference? Let's say Vc equals to 0. Why equals to 0? Because charge gained some energy from this battery. It lost that energy at IR, and it lost and some energy is stored in the capacitor in form of electrostatic potential energy, which is Q times Vc, right? So it's all about where the charge is getting the energy and where the charge is getting dissipating the energy, or where the charge is contributing the energy. Okay, so it got energy from somewhere, it has contributed in heat energy of the resistor and electrostatic energy storage of the capacitor. So we have gotten a statement which is QE minus QIR minus Q into Vc. If I will take Q common, E minus IR minus Vc, I realize that Q cannot be equals to 0. Therefore, E minus IR minus Vc equals to 0. This is the statement of Kirchhoff's voltage law. So, Kirchhoff voltage law, in terms of EMF and potential drop, what it says is all the EMF of the battery of the circuit, all the EMF in the circuit, and all the potential drops across every element, every element adds up to 0, adds up to 0. I will take some more examples and I will tell you how to apply this Kirchhoff's law. So what it is doing, it is just telling where the charge is gaining energy and where the charge is losing energy. Okay, we will do one question and you will have the idea how to apply this law in a very basic manner. We are going to take a circuit. there is one resistance R1, there is another resistance R2, there is a battery, there is a key, and the key is closed. This is a closed circuit. Okay, so uh, I will take this EMF of the battery as this is the key which is closed. How to apply Kirchhoff voltage law? First, we will assume the direction of current coming out of the battery. We can assume any direction if our calculation is, uh, if our assumption is not correct, then we will get a negative sign in the value of the current. So I will assume my current in this direction coming out of the positive terminal, and it is going through these two resistance, and it is coming back to the battery. Okay, now understand. To apply Kirchhoff voltage law, take any point on the loop. Since here is one loop, here is one complete loop. What I'm saying is loop is what loop is this. This is one loop. Okay. So yeah. Okay. So I will take a point in the loop. I will say that this point has potential VA. This point is A. Okay. So whatever is this point, whatever the potential of this point, doesn't matter whatever you will assume. You can assume it as zero as well. It will be proved in a couple of minutes that it doesn't matter what you will assume the potential at A. So I will assume the potential at A is VA. Okay. And I will start moving in the loop. I will start moving in the loop like this. You can choose any direction. I am choosing to move clockwise in the loop. So I'm moving in this direction. I will cross the battery. And when I will cross the battery, this uh, uh, the charge is starting from this point. It has potential VA, and when I will cross the battery, it will gain a potential of E. Why? Because this is lower potential, this is higher potential, so it is going from lower to higher potential, so it is gaining a potential of E. Now, since I have assumed that the current I is flowing in this circuit, in these branches, so across this resistor, the potential drop must be IR1 according to Ohm's law, and the potential across this resistance R2 is IR2 according to Ohm's law. Okay, now I have to decide which is higher potential and which is lower potential. So R1 is at higher potential, sorry, left end of R1 is at higher potential and right end is at lower potential. That's why the current is going from left to right, right? So the potential will be dropping if I am going from higher to lower potential. So I will put a drop of minus IR1. Now I have crossed this resistor, and I'm again going to cross this resistor R2. If I will cross the resistor R2, I will again get a potential drop of IR2. Why drop? Because this is plus, this is minus. That's why current going from higher to lower potential. So when our charge will go from plus to minus, it will again lose some potential, which it will the potential will be dropped, and the potential drop will be IR2. And again, since we have reached here, and from here to here, there are no element present. So whatever is the potential here, the same is the potential here. So the potential here should be equals to VA. You can see VA and VA got cancelled. You could have assumed VA equals to zero. Okay, so you didn't have to go through the formality of assuming VA. You can just write it as zero, and you can do the calculation. So from next time, I will write all the EMFs and drops and make it equals the sum, I will make the sum equals to zero. Okay. Now I will solve this for the value of current because the purpose of the question was to find the value of current. The value of I came equals to E divided by R1 plus R2, and we have got the value of current. Now the question might not be that simple, which would have been given in the exams. They would have been asking what is the potential drop across resistance R1. So the potential drop across resistance R1 is IR1. but you can only tell when you know the value of current. We know resistor R1, but we don't know the value of current I. So if I will write the value of current I here, it will be E by R1 plus R2, which I have just calculated times R1. That is V R1. If someone has been asked the question, find the power dissipated across R2. The power dissipated across R2 is I square. That's how we find the power, right? How do we find the power? We find the power I square R, right? Let me write it again. It is looking cumbersome. I I square R2. What is I? I is E divided by R1 plus R2 whole squared times R2. This is the power dissipated across R2. That's all. That's how we are going to apply Kirchhoff's law in a circuit with a single loop. Let's take one more example. I'll take a random circuit. Uh, there is a battery. The battery is, let's say, 100 volt. There is a resistor of 3 ohm. There is one more resistor of, let's say, 7 ohm. There is one more battery. It's also 100 volt. There is one more resistor, let's say, of 10 ohm. There is one more resistor, here, one battery here, and there is one more resistor here. So I'll take 2 ohm, 3 ohm, and 15 ohm here, and I will take this as 200 volt. I have just drawn a random circuit. Let's try applying KVL, Kirchhoff Voltage Law, and our purpose will be to find currents in all the branches. To find current in all the branches. Okay, so let's do that. For that, the first step we have to do is we have to assume current in all the branches. Okay, you can assume current in any direction in any branch. Okay, so what I will do, I will assume current I1 going from here, and current I2 going from here. Whatever current I1 is going here, current I1 is going through all this branch. Okay, we know that unless the branch changes, the current stays the same. So current I1 is coming from here and current I2 is coming from here. At this point, they will combine and go here, and here the current I1 plus I2 is going. We haven't done the Kirchhoff's current law yet, but this is a basic thing you can understand. If some charge per second is coming from this branch and some charge per second is coming from this branch, the total charge will be going per second, right? So that's how the current works. It's a very basic scalar thing. Okay. Now we are going to take two separate loops. Kirchhoff's voltage law is also called loop law because we are going to take two loops. In both loops, we are going to choose some direction in which we are going to move in the loop. Okay, so I'm taking clockwise direction in both the loops. You can take any direction. I will suggest to go with clockwise or whatever is your default. But every time you just take one single direction and start take one loop and start at some point. So I'm going to take one loop. Okay, so I'm going to take loop 1. This is my loop 1. This is my loop 2. So I'm taking loop 1 In loop 1, I am going to start from this point. At this point, I will assume the potential is 0. Okay. By the way, I am telling in one single circuit, you can assume one point having 0 potential as the reference point. Whatever is your reference point, you can assume any potential, you can give any potential value to that reference point. I am giving it as 0. Okay. No other point in the circuit, you can randomly just give any value if you have given value to one reference point. Okay. So I have given 0 to this point and I am moving in this circuit in this manner. Okay. And when I will cross this 7 ohm resistor, I will get a drop of 7I1. Agree? Why drop? Because current is going from plus to minus. So I will get a drop of 7I1. And I will cross this battery. Because in this battery I am going from minus to plus, I will get a potential raise. I will get a raise in potential of 100 volt. I will not write volt here. Why I will not write volt? Because it will confuse with V. Okay. Now I will again cross this 3 ohm resistance. The current is going from here to here. So this must be higher potential. This must be lower potential. So I am getting a drop while crossing the resistance. So I am writing minus 3I1. And now I had been in the loop from here to here and then cross 3 ohm resistance. I have to complete the loop. So I'm coming in this direction. I will cross this battery. I will cross this battery. I will see that this is plus, this is minus. So I'm going from plus to minus. If I follow the loop direction, I'm going from plus to minus. So if I'm going from plus to minus, I will write I lost some potential. So it will be 100, whatever is the potential of the battery, potential difference across the battery. And I will move across this 10 ohm resistance and I will see in this 10 ohm resistance current I2 is going like this. So current I2 must have been going from plus to minus. And how much potential drop across this 10 ohm? 10I2. So will it be a drop or gain? Since our loop direction is this, we are coming like this. This is minus and this is plus. We are going from minus to plus. So we are gaining something. Minus to plus means we are gaining something. So we have gained 10I2 potential and we came to this point back equals to 0. Now, let's simplify this equation. 100 got cancel. 10I1 minus 10I1 is equals to 10I2. Oops. Minus 10I1 plus 10I2 equals to 0. So I1 we got equals to I2. This is our equation number 1. Okay. Similarly, we will take another loop, loop number 2. Loop number 2. In loop number 2, again, we are going to move. We are going to move from this 0 and we will go like this. We will go like this, right? So we will start from this point. Let's see how we will write all the drops and gains. So starting from 0, I will cross this 10 ohm resistor. If I am crossing this 10 ohm resistance, I am going from plus to minus. If I am going from plus to minus, I am losing 10I2 potential. Okay, my loop direction is this, right? That's why I'm going here. If I will cross this battery, I will gain some potential because this is minus, this is plus. I'll gain some potential. How much potential I will gain? 100 because I'm going from minus to plus in the battery. Across this resistor 2 ohm, I am going in this direction and the current is also going in this direction. So the current must be going from higher to lower potential. So we are losing the drop of 2 I1 plus I2, right? I1 plus I2. When we will cross this battery, we are going from minus to plus. So there will be a raise of plus 200 volt. Again, when we will cross this resistor of 3 ohm, we are going to get a drop because the current is going from plus to minus. So we are going from higher potential to lower potential in the loop. So we are losing minus 3 I1 plus I2, and across this. Okay, so now, uh, yeah, there was some technical error. We got now we know how to. We wrote this statement of KVL in loop second as well. We will move further and we will get one more equation from here. The equation will be minus 10 I2 minus 10 I2 plus 100. 2, 3 and 15 will become minus 20 I1 minus 20 I1 plus I2 plus 200 equals to 0. So this will become nothing but minus 10 I2. Since we have got I1 is equals to I2, I will take 20 I1 plus I2 will be 2 I2 plus 200 equals to 0. We will further solve it. We will get minus 50 I2 plus 200 equals to 0. Further solving it, I will get I2 as 200 divided by 50, and we are getting 4 amperes. So I am getting I2 as 4 ampere. It will give I1 also has 4 ampere. The current in the branch I1 is 4 ampere, I2 is also 4 ampere, and I1 plus I2 is 8 ampere. We know the current in all the branches, and since we know the value of current in all the branches, we know the value of power dissipated by all the resistor, we know the power provided by all these battery. Let's say someone is asking what is the power provided by this battery. So the power provided by this battery, power provided by this 200-volt battery is E times I. What is he? E is 200, and what is I? I is I1 plus I2, that is 8 ampere. So 1600 joule per second. This is the power provided by battery 200. What is the power dissipated by this resistor 10 ohm? The power dissipated by 10 ohm resistor is I square, which is through I current through 10 ohm into R, which is resistor 10 ohm. I square R. What is the current through 10 ohm? It is nothing but it is 4 ampere. So 4 square into 10. The power dissipated by the resistor is 4 4 is 16. 160 joules per second is the power dissipated by 10 ohm resistor. Okay, so that's it for today. We are done with the Kirchhoff voltage